Hi friends, in this video I am going to make the topic of real numbers really easy for you. We are going to looking at the concept by practicing some important questions on real numbers. I am going to take showing you the tips and tricks on how to solve the sums. Friends, I recommend you to pause the video here and go and get a pen and paper so that we can solve that together. So, are you ready to dive into the real numbers? Natural numbers. First one is natural numbers. So, what is the natural numbers? The definition is very important. All counting numbers starting from 1 is called natural numbers. It is denoted by capital N. So here N is equals to the counting numbers 1, 2, 3, 4, dash, so on. This is the natural numbers. The second one is whole numbers. So what is whole numbers? All counting numbers along with 0 is called whole numbers. Is denoted by capital W. So here all counting numbers along with 0. So 0, 1, 2, 3, so on. This is the whole numbers. The third one is integers. So here, what is the integers? Very easy. The combination of negative numbers and positive numbers along with 0 is called integer. It is denoted by I or Z. I or Z is the combination of negative numbers and positive numbers along with 0 is called integers. See here is a positive numbers and negative numbers along with 0 is called integers. The fourth one is the rational numbers. So what is the rational numbers? The definition is important. The numbers which can be expressed in the form of P by Q. P comma Q are integers. Q is not equal to 0 is called rational numbers. Is it P by Q? Here Q is not equal to 0. Condition is very important because the denominator is 0. It is a non-defined. So that's why Q is not equal to 0. Here P comma Q are integers. Okay? So this is denoted by Q. Q means it is nothing but quotient numbers. So what are the rational numbers? 2 by 3, minus 5 by 7. 0 also is a rational number because 0 by 1. See, all rational numbers are also rational numbers. For example, we are taking first 1. 1 is a rational number because 1 by 1. The next is 0. 0 by 1 is equals to 0. So that's why we are taking whole numbers also rational numbers. For example, we are taking minus 3. Minus 3 also is a rational numbers. So sometimes we are taking perfect squares. Root 4 is equal to what is the value? 2. 2 also is a rational numbers. Okay? The next topic is fifth one. It is the irrational numbers. What is the irrational numbers? Irrational numbers. The numbers which can't be expressed in the form of P by Q. That is called, it is the irrational numbers. See, once again, irrational number. The numbers which can't be expressed in the form of P by Q. P comma Q are integers. Q is not equal to 0 are called irrational numbers. It is represented by, it is denoted by Q dash or S. S means it is a source. So, we are taking root 2, root 3, root 5, so on. Because root 4 is a perfect square, so that's why root 4 is a rational number. So, except the perfect squares are root 2, root 3, root 5, root 7, root 8, root 10. These are the rational numbers. So, now coming to the real numbers. The combination of real numbers and irrational numbers are called real numbers. Or, one more definition, the combination of natural numbers, whole numbers, integers, rational numbers and irrational numbers are called real numbers. It is denoted by capital R. Here, N means it is a natural numbers. N subsets of W. W subsets are I subsets are Q. Define Euclid division lemma. So what is the definition? For any two even positive integers A and B, there exist unique whole numbers Q and R such that A is equals to BQ plus R, where 0 less than or equal to R less than B. See, this is very important. What is the A? Already we know that division algorithm. A is equals to dividend, B is equals to divisor, and Q for quotient, R for remainder. So the condition is very important. R for remainder. So the remainder is always greater than or equal to 0, less than B. Okay? Euclid division theorem. For example, the first question is 50 and 70. 50 and 70. Here 70 is equals to dividend, 50 is equals to divisor. 50 is the divisor, 70 is equals to dividend. Taking 50 table, 51 the 50, the remainder is equals to 20. Here dividend, divisor, quotient and remainder. So what is the Euclid division theorem? Already we know that this formula is equals to A is equals to BQ plus R. A is equals to dividend is equals to 70. B means divisor is equals to 50 into Q for quotient. What is the quotient? 1. Here plus. So R means remainder is equals to 20. This is the first step. Next, coming to the second one. Here the divisor is equals to 50. Now 50 becomes a dividend. So 22 is 40. The remainder is equals to 10. Here, what is the dividend? Dividend is equals to 50. So divisor is equals to 20. Here, what is the quotient? Quotient is equals to 2 plus the remainder is equals to 10. Clear? The next one is here the divisor 20 becomes a dividend. 10 twos are 20. The result is 0, the remainder is 0. Here HCF is equals to 10. Okay? So now the next step is here dividend is equals to 20. Divisor is equals to 10. And quotient is equals to 2 plus the remainder is equals to 0. So the remainder is 0, the HCF. Here HCF of, so what is the question? 50 and 70. 50 and 70 is 10. This is the answer. Find the HCF of Euclid division theorem. The first question is 900 and 270. Solution is by using Euclid's division lemma. So what is the formula here? A is equals to BQ plus R. So before that, you can find the HCF. So what is the here? 270 is the divisor, 900 is dividend. So 27 3s are 81. So the remainder is equals to 90. Here. So here what is the dividend? Dividend is equals to 900. Then A is equals to 900. And B is equals to divisor. What is the divisor? 270. So what is the quotient? Q for quotient is equals to 3 plus remainder is equals to 9. Clear? The next step is, so here 270. Now coming to the 92, 9 ones are 9, 9 twos are 80, 9 threes are 27. So 93 are 27. The result is 0. Here the remainder is 0. So what is the dividend? 270. So divisor 90. The quotient is 3. The remainder is 0. So now HCF of 900 and 270 is, what is the answer? 90 is the answer. The SPF of 900 and 270 is 90. The question is, use division algorithm to show that the square of any positive integers is of the form 3p or 3p plus 1. So solution. Here, let A be any positive integers. Any positive integers. Here, B is equals to, what is the value? B. So 3. So we are taking B is equals to 3. By using division algorithm, here A is equals to BQ plus R. A is equals to dividend, B is equals to divisor, Q for quotient, R is equals to remainder. So here B is equals to, already we know that 3. So what is the condition? 0 less than or equal to R less than B. Here B is equals to 3. So that's why we are taking R is equals to 0, 1, 2. Clear? If R is equals to, so first value 0. If R is equals to, we are taking 0. You can substitute the values. A is equals to BQ. So what is the B value start here? B is equals to 3. 3Q plus R is equals to 0. Then A is equals to 3Q plus 0 is equals to 3Q. The next one is squaring on both sides. Squaring on both sides. So now here A square is equals to 3Q whole square. So A square is equals to 3 into Q square. So A square is equals to 3 into 3Q whole square. So here A square is equals to 3P. Here where 3Q square is equals to, we are taking P then. So this is the first. There. Next, if R is equals to, we are taking, so 0 is completed, we are taking 1. So if R is equals to 1. Now write the division algorithm. A is equals to BQ plus R. So A is equals to, what is the B value? B is equals to 3. 3Q plus R is equals to 1. Now squaring on both sides. So A square is equals to 3Q plus 1 whole square. Next, A square is equals to, here A plus B whole square. Expand A plus B whole square. A square plus 2AB plus B square. So here A square plus 2AB plus B square. Okay. So A is equals to 3Q. Then 2AB 3Q plus 1. Here 1 square means 1. Okay. So we are taking A square is equals to 3 into 3 Q square plus 2 into 3 into Q plus 1 square means 1. A square is equals to, here 3 is the term. So what are the remaining? 3Q square plus 2Q plus 1. Here A square is equals to 3P plus 1. Where 3Q square plus 2Q is equals to, we are taking P. Okay. So next, here the square of any positive integer of 3P or 3P plus 1 or the square of any positive integer. Okay.